Yeah, so again, good morning, good evening. Today's session is more on problem solving tools, what we use in industries, and then when to use which tool. There are millions of tools, but we'll be covering about six, seven tools today. And I will be, they're all technical tools, probably some of you have already used. If not, we'll have an engaging session. It's not like, I'm going to get you all bored with all the presentations. We'll take a tool, we'll discuss, and then we'll go to the next one. Right, with that, let me start sharing my screen and then we'll also see if possible in the end, we'll have some group discussion to really understand this tool and then and then I'll be sharing the presentation with you guys. So you can definitely use it whenever you want it. Let me know if you guys can see my screen. I'm sharing.
It's coming through. Yep, we can see now.
Perfect. Good. Thank you all. We will see most of the practical framework, right? How they are used in industry is not about how they use real world case studies and also some actionable insights for us. We as a leader, right? How should we use those tools? Whenever there is a problem in industry, how we can take them and also we can have a discussion with anybody else. So you can stop me anytime if you have any question. 70% of organizations are facing chronic recurring operational problems. It means most of the organizations don't solve problems effectively. Almost $3 trillion we lose annually to inefficient processes globally based on McKinsey study. Huge. It means we have less problem solving leaders. And if you solve problems effectively, there's almost 500%, 5x return from structured problem solving programmers. So if you really have a good program in your organization where people use a tool and you solve problems effectively, you will be getting almost 5 times more ROI from the tools. Look at these statistics. Then why problem solving? Like I talked about, companies waste almost 500 billion annually on poorly defined problems. What this means? In our last discussion, Krishna sir mentioned about if you define a problem, 50% of the problem get solved, right? So what this means, anywhere you go in organization, at least based on my experience, and you can also share your, mostly people do not define the problem correctly and hence everybody jump onto a different kind of solution or they don't solve the problem or they don't know exactly what's the problem. And then also if you don't take action, almost 20 to 40% of the problems will keep coming and then if you don't use a structured problem or you don't use structured problem solving tools, we always have problems. And then if you have those structured problem tools and approaches, you will be able to solve almost 40% faster, 20 to 40% faster resolution. And then if you are in a C-suite or any of the roles that you are in, if you master these tools, you will be kind of the star in the organization because you understand the problem, you use a tool and you solve a problem, people will come to you. Then you will be spotted as the high potential talent in the organization. Like we talked, 50% of the problem gets solved when you define the problem correctly, right? The code, the formulation of a problem is often more essential than its solution. So if you know then you have almost 50% of the job done. And some of the tools, right? We have talked about, Krishna sir talked about theory of constraint. Even I wrote an article on this. So we'll talk about that tool. 5 whys is a very, very industry-wide used tool for root cause analysis. We'll talk about it. PDCA that we use in mostly all the quality system managements stands for plan, do, check, act. It's a continuous improvement cycle that we use. So anything you want to do, first plan it, then go do it, act on it, and then check whatever your results are, and then based on that adjust or act. Again, you can go on continuous cycle, right? Ultimately, plan, do, check, act. Then Lean and Six Sigma is widely used in almost all the industries, be it in IT or manufacturing or finance. Wherever there is a large scale of complex problems, you can use Lean Six Sigma to reduce waste. Lean is all about waste reduction. Six Sigma is reducing variations in the process. Fishbone diagram in normally manufacturing team and others might have used. This will help you identify the cause of the problem. Then mostly you have seen Pareto is used widely. We cannot solve all the problems, but if you focus on top 20%, your 80% of your problems will go away. Then we will cover these tools today. One, theory of constraint, little bit. How do you identify bottleneck and throughput? So if you have a manufacturing or an IT or finance organization, you need to be able to identify what is your bottleneck. If you identify the bottleneck, how do you know which one is bottleneck? You need to map it out and then understand what is your output, where exactly entire work is filed, and then you will be able to focus on that particular process or the business system. You will be able to solve the problem for that particular organization or the process. Then we will talk about 5 why analysis, how it is used in IT or root cause analysis. DMAC will touch upon little bit about how DMAC is used and what it stands for. Some of you have already a green belt, yellow belt, or black belt or master black belt. If you know it, maybe you can also add in your input here. When there is a large scale process improvement is required, how Six Sigma is used. There are two different. There's another tool called DFSS where we used to use design for Six Sigma. If you are designing a product or designing a process, you use certain tools in the design stage itself so that your process delivers capable output. That's where you use DFSS. But today we'll be covering DMAC, which is more of a how do you identify, define the problem, measure it, analyze the problem, and then how you improve and control. That's what we'll cover a little bit. A3 thinking, this is used widely in almost all the shop floors where there is a lean and operation excellence. You'll see A3 as a great thinking and lean tool, which is widely used in supply chain and distribution. FMEA, most of you have probably heard. If not, we'll cover. It's more of a risk analysis tool. How do you prevent risk ahead of time? It's widely used in across all the industries. And then the last one, 8D problem solving. This is also widely used by automotive industry. I'll stop here. I want to know anyone of you have heard, use any of these tools.
Yeah, pretty much all of them.
Great. Very good. So then you will be also kind of, a speaker on along with me to share your practical ideas, insights. We'll talk about one by one. We'll spend maybe 5 to 10 minutes on each tool, and then we'll see how many of you have not heard any of these tools or kind of. Anybody has not heard or used these tools? Or anything you think, hey, it should be covered so that you understand it better?
I haven't heard, of course, Lean Six Sigma, yes, but I didn't explicitly hear about DMAC, A3, FEMEA. These three tools are new for me. But all, yeah.
Okay, great. Jaya? Okay. Anybody else?
Sanjeev, use these tools, but not by this name. Okay, not by these names. Okay, just the framework. Okay.
Okay. So I want to make sure that it is useful for everyone and then we'll have a discussion. Okay, great. Now again, I'll start sharing. Can you all see my screen? So theory of constraint, let's talk. This is widely used tool to find the bottleneck. If you have a system and if the bottleneck is limiting your entire system's output, then how do you exploit it? How do you understand where the problem exists? That's when you use theory of constraint. That is called TOC. We touched upon this last time, but I'm just taking you through step by step. The first step in TOC is identify the constraint. Sir talked about primary, tertiary, and we talked about primary, secondary, and tertiary problems. So identify constraint is the first step. How do you know where is the constraint in your organization? It's easy on the manufacturing floor, because when you walk on the floor, you see that the bunch of inventory sitting and the machine is slowing down the entire process. You know, oh, there is something going on. So you can identify the constraint. But most of the organizations in IT or in project management, or you're working on any improvement, how do you identify the constraint? Any thoughts?
Cycle time analysis.
Perfect. Yes. Cycle time analysis. You identify, first of all, map all the processes, and then for each process, identify or ask questions. Okay, how much time it is taking, right? For example, imagine there are 5 processes. Process 1, 2, 3, 4, 5. And then process 1 takes 30 seconds to produce a part or to execute things. Process 2 takes 45. Process 3 takes 2.5 minutes. Process 4 takes 10 seconds. Process 5 takes maybe another 60 minutes. So what is the bottleneck here? The bottleneck is which is having the highest cycle time, right? 2.5 minutes, process 3. So first of all, measure the throughput or the queue length, and then you will identify, oh, here is where most of my time is spent. And then second step is exploit. Go squeeze the maximum output from the bottleneck without spending money. Eliminate idle time, defects, changeover at the first step. So what this means, if you have a process which is taking 2.5 minutes and all other processes are less than a minute, you will always go and focus your attention on that process. Say why it is taking 2.5 minutes. What do we need? Okay, is it because of man, material? Is it because of the people not knowing the process, or the training issue, or it is because somebody need to bring the tool from somewhere else? So there are a lot of things you can understand and then say, hey, what if I have all those things available in this station? Can I reduce from 2.5 to 1.5 a minute per pot, right? Then you go further. So first of all, then second step is exploiting. Third, subordinate everything else. Make all other constraint step feed the bottleneck at its pace. Stop pushing more work into the system than the constraint can handle. So if you just imagine what happens if I go and improve process 1, because it's easy thing, okay, but it doesn't impact your entire output. your organization will suffer because you have bottleneck in some other process or other stations. Then elevate the constraint, right? Exploitation is not enough, invest, right? Then think about you have a machine which is taking almost 2.5 minutes per part, and you have only one machine, but all other processes are less than a minute. Can I invest one more machine parallel to that so that all I can put two operator, two machine and reduce the cycle time by half, or do something that will then I'll break entire bottleneck into steps. Imagine it has got 10 steps. Can I do those 5 steps in this station and another one in 5? So can you break it out so that the flow can be improved, right? Then fifth step is repeat. Because once you break a bottleneck, there will be something else becomes a bottleneck now. Because you have now, imagine there is 5-step process, one step was 2.5, you break it down, you invested money, now that is like less than 30 seconds. Oh, what happens? Now that bottleneck is not there, but there is something else. We talked about process 5 taking 60 minutes. Let's go there. Let's find out, again repeat the same process, right? So this is where, you can rate your system, where exactly money is generated through sales, and then you can have a matrix and then identify how and where your money is stuck. Why you are not able to make money most out of the entire process or the organization, right? Use this method to solve problem. If there is an inventory problem, there's an operation excellence problem, or whatever in terms of your constraint, right? Always think about how do you measure your WIP. WIP is work in process, right? Queue at every step, and wherever the largest queue is your constraint. Fix it before investing anywhere else. This is how theory of constraint is used. And then I'll take an example here, real world example, right? So imagine there is a problem. On-time delivery is 62%, 3 week finished good, backlog despite abundant raw material. Just a manufacturing example. Then when we identify welding cell processing only 140 units per day versus upstream is feeding 200 per day. So WIPQ is almost 3 weeks, right? Then go and exploit. Eliminated 40 minutes per day changeover at welder. So what they did, they went ahead and looked at the welding process and then moved up QC inspector permanently to that cell. Because earlier QC was used to be about maybe 5 minutes walk from that particular cell. So now you brought in that person, do all the inspection here so that you don't have to go there, right? And then cutting and machining tool to run at 140 units per day, not 200, because that was your bottleneck. So now WIP operated in 4 days. So I think you had one more skilled worker who is a welder on second shift, so that you are not really only focusing on one shift but the second shift, and then basically you increase your OTD. OTD is on-time delivery for the people who do not know, rose from 62 to 94%, right? Lead time reduced from 18 to 6 days. Revenue went up by $4.62 million in 6 months, right? For example, IT desk, there is a backlog of IT tickets routed through tier 1 FAQ path, and then if you use this, you can reduce by 55% in 30 days. So some of the examples, ultimately, this is from manufacturing, but you can use it in anywhere, right? If there is a cycle time reduction, you can definitely use this in your day-to-day life. Always ask question, where is the work piling up right now, and where is the constraint, right? And then don't approve your capacity or upstream unless you know the bottleneck, right? If you go and approve the capacity or investment somewhere else, that is not going to help you. in organizations. And make constraint utilization is number one operational KPI until it moves. So always keep looking at bottlenecks and constraints, then you will be able to use this tool anywhere in industry. I stop here. I would like to have the discussion. Maybe Tim, do you want to share anything from your side or anybody else?
Yeah, I could share something real quick. Actually, when you're talking about the theory constraints and the cycle time analysis, I was thinking about a situation we have right now. So if I could share my screen real quick,
Sure.
I'll show something here. It says host disabled participant screen sharing.
Oh, can you just ask for request?
Hmm. Hmm.
Normally, I should be able to approve it as soon as it comes. Is there anything like request screen share? Oh, yeah. So now you should be able to share. Now I said multiple people can share.
Okay, thank you.
Yes, perfect.
Okay, can you see that?
Yes.
So this is a process we have where we have two lathes, CNC lathes at the beginning. So we have raw tubes coming in. These are both operated by robots. And then the robots feed an automated pierce line that has automated transfer system. And then over here, we have a welder that's fed by an operator. And then over here, we have a vertical machining center that's ran by an operator. So this is a situation where if you look at just cycle time, like if we do a cycle time analysis, you'll see that this front end has a 13.6 second cycle time. All right. This has a 10-second cycle time. This is 12.1. This is 10 seconds. So by cycle time analysis, this is the bottleneck. However, when you dig a little deeper into it, you got to consider the OEE, the overall equipment effectiveness of each individual section of the line. With these being robotic driven, we have a much higher OEE over here. You don't have, the robots don't get tired. They don't take breaks. They don't go to the bathroom. They just run, right? So this front end over here yields a 95% OEE, which means we can net about 251 pieces an hour. Where if you go over to the welder has an 81% OEE, which means it can only net 240 an hour. So by cycle time, right, this is the bottleneck. But when you look at OEE and all the other factors that play into it, this can quickly become the bottleneck, which is why we end up putting like a couple buffer systems in here. So when this goes down, if they have to do a robotic tip change on the welder or something's wrong with the fixture, this keeps running and puts parts right here that the weld operator can grab from.
Great.
But in parallel, so that's a temporary thing, but in parallel, what we're doing is we're trying to increase the cycle time over here and increase the OEE over here in order to get a balanced flow.
So you are increasing the cycle time in the first one?
Yes, we're going to increase the cycle time here.
Yeah.
And increase the OEE here.
Okay. Because OE is, it is 81%, right? Remaining all is 96%. Yeah. And those of you who do not know OEE, OEE stands for overall equipment effectiveness. It's a combination of how, is your equipment available? Is it performing to the rated speed? And the quality is good. So all the three, multiplication, availability, performance, and quality, the multiplication is called OEE, operational, or maybe overall equipment effectiveness. Cool. Very good example. This is a practical way how TOC can be used and how it is applied. And you can see some parameters there, right? So on the first slide, when near the bottleneck, you see availability is 95%, right? Performance is 100%, QE is 100%. So when you multiply 95 into 100 into 100, what becomes is 96, right? And then net,
95. 95.
oh, 95, yeah. And then the net, yeah, now I can see it. Good. So what is the net is the output? 250.75. What it was
251 pieces an hour net.
net? Got it. And it operates two shifts and 7.668 hour per shift. Because why 7.8? Everybody will ask, why not 8-hour shift, right? Normally it is 7.6 because you always consider the efficiency and then people brag. There are so many planned downtime as well.
Yeah, that has like a cleanup time, a break time.
Correct. Exactly. So, and then you have 3,861 pieces per day. And you can see if you do multiplication, it is 19,300. So these parameters will help you. So what Tim and team did is they put all these parameters. What is happening? So just put all the constraints and then all the parameters and then measure them. Once you have this data, then you can easily identify where is your bottleneck, what is. So it is more of a math, statistical calculation. It will help you identify the bottleneck and then you resolve. So once they invest in this bottleneck, they invest in this welding process, you will have one more bottleneck afterwards. But this is how you will keep on improving continuously.
Just if we can take few minutes on this example, can we walk through? I mean, actually, personally, I see it's a 95%. Everything seems to be so good. So what is the bottleneck?
The bottleneck is this front
Even
end
I
right
have
here.
the same question. What is the bottleneck here? I couldn't able to get that one.
The bottleneck is this area here, this robotic cell, where we have two CNCs, which
So,
are
yeah,
cutting.
let me make it very easy. Just look at the cycle time of lathe. The first machine, Morishiki, 30-second cycle time, right? Second one, Tongtai, 24.4 second cycle time, right? Go to the next one, Pierce, 10.10. Then go to Welder, 12.10. Go to Silky, another one, 10. So where is cycle time high?
Oh, 30 seconds.
Correct. So 30 and 24, that's where entire work is piled up. That's where they said it's a bottleneck. So he combined 13.6 seconds he put together to now he split that entire operation. With that also it is 13.6, right?
Yep.
Sanjeev, will adding a one more machine will be a solution to it?
See, if you add one more machine, what will happen?
Put will go, for example, if we add up a one more Tongtai machine, it will operate at the 24.46 second. So probably will increase the throughput by another 50%.
But it will give pressure on other areas.
Correct.
Like
Right.
Exactly. Because even you add that investment, imagine you invest, another whatever, $1 million. Do you really think it will, rather than that, I'll go and then fix that welding process where, you have the next bottleneck 12 seconds, right? Hey, if I can do some kind of parts spare or that person can go and do something, then it will, because then if the bottleneck is not there and you're trying to do more work behind the scene, that's just waste investment until unless you crack the next one, right? So I'm not saying, but always look at what is the customer demand, how much they need, at what cycle time you want to operate, and where in the entire chain your constraint is. So Raga,
Only a thought here, because in the second process we see that it is producing 5187 pieces per day.
yeah, 5,187 pieces per
Whereas
day.
the first
Right?
operation is producing 3861.
Correct.
Or will the slowing down second process will do the
Yeah, you see now again, that's a very good point. The first per day 3,861, per day 5,187, and the next process welder is 3,689. So next bottleneck, once you crack this, it becomes welder, right?
Mm-hmm. Yep.
Because per day you cannot even go beyond that in the entire flow. If you invest again here, one more, you already at 3,800. You will have, imagine another 5,000. What is the use of that? Because ultimately everything will go and pile up at welder.
Yep.
Yes, yes.
Does it
So
make
what
sense?
should be the, so if we consider this, what should be the solution, team?
So what we've got going on, the first thing is we want to get this with an improved cycle time, which what we're doing is you can see this CNC right here, it runs at 24.4 seconds. This one runs at 30 seconds. That's a big difference. So the reason is this CNC, it has a collet style chuck on it. And this has a 3-jaw chuck. That's an older style spindle. So what we've done is we've purchased a new spindle we're going to install in here. That's going to allow us to increase our feeds and speeds on that machine, which will increase the cycle time of it. So we're going to be able to get this CNC around the same as this. And then also we found opportunities with the automation over there. The doors to the CNC, they open and close automatically. But what we're finding is like the machine doesn't start moving until the door's all the way closed. Like the spindle should start spinning while the door's on the way to closing. Same thing with some of the robotic movements. Like the robot's waiting for certain things to happen where it could be doing motion at the same time. So I think we can get this area here close to this 10 seconds here. And then we're going to work on getting that welder down to that same around 10 seconds. And the whole line will be around 10 seconds.
So every 10 seconds you'll get a part.
Yep.
That's the idea logic, right? So that's where they're focusing on what is the highest cycle time first, then go to the welder. Then once everything is streamlined, you'll get every 10 seconds one part. So that's how everything will be meeting the demand. Then if they want to improve that further, imagine they want to reduce that 5 seconds. Now the demand increased. So now you need to think about, okay, do I need to increase all the machines or where is the bottleneck next time, right?
Yep.
Then go on exploiting. So this is a great example, practical, how theory of constraint or bottleneck analysis can be done. Anybody has any question? Raga?
Yeah, I have one question, Sanjeev, to the Lavanya and team. Did you get the answer of even at 95% or 90%? Sorry, I'm not on the video because I'm traveling. At 95%, why is it still called a bottleneck? Correct?
Correct.
That was Lavanya's question and I don't know, Raga's question.
Yeah, perfect.
Yes,
Did you people get the answer?
Yes, sir.
What is the answer?
Sir, give me 1 second, sir. So you are referring to 95% of availability. Are you referring to that, sir?
Yeah. See, you asked the question, no? Is 95%, why still it is a bottleneck? Correct?
Yeah.
Did you get the answer? If yes, then what is the answer? Or am I confusing the question?
No, it's very valid question, sir. Yes, it's making us to rethink.
Yes. Did you get the answer? At 95%, why you still call a bottleneck?
Because the end goal is we need to get a part in 10 seconds. But because of that first step itself, in lathe itself, we are taking 30 seconds, even though it gives 95%.
Yeah, it's 95%.
We are not.
Why bottleneck then? That's the question.
So is like expectation, it should be like around 97 efficiency, the goal to be
Even
met.
then it can be a bottleneck.
Yeah, I think the
Isn't that
requirement
right? So my question is beautifully done. Did you get the answer?
No.
Okay, can I just put it? This bottleneck is from business perspective. Okay. What if you have an order to be delivered? Team has to deliver an order of 4,000 numbers a day. I'm not able to say, is it 4,000 a shift or day or something? I don't know.
Yeah,
Is that correct, Tim?
3,861 pieces
Yeah.
per day.
So if the order team is getting for 4,000 a day, then this 95% becomes a bottleneck. So it's all business driven. Suppose he's having orders only for 2,000. Will he ever consider this line to be a problem?
No,
No. So where is the bottleneck meaning coming from?
business
This
perspective.
perspective.
Business. That is where you should have a wider outlook. You see,
Mm.
if the business order is only for 2,000, why team and team should look at this at all? Correct? It will
Well,
never
I
be a
think
bottleneck.
even if we were making the orders, which we are now, we would still look at it because from a business case, my thought is I'm running this 10 shifts a week. I want to run it 6 shifts a week and reduce the cost.
Yeah, because you have orders coming, isn't it?
Yeah, and I want to use the labor
Yes.
somewhere else.
Yes, somewhere else. So he has a definitive business. If the business is not there for this, then this will not become a bottleneck. So even at 97%, if he's getting 10,000 numbers a day, will it be a bottleneck at 99%? Yes, because he has business which he cannot serve, which he cannot make money. Ultimately, business is to make money, correct?
Correct.
Oh yeah.
Correct, sir.
So he will still consider to be, if he's having 5,000 orders per day, per month, then 99% is also going to be a bottleneck. So it's a bottleneck from which consideration? Business considerations.
Super, sir.
Good. Does it make
Actually,
sense now?
yes, sir. Actually, what initially my thought was, in part A, in lathe, we are producing less number of part, and in other areas we are consuming, we are waiting for the part. This was
Correct.
my understanding, but now I got the overall picture. Like business itself, they are suffering because they could not able to deliver the correct number of parts. So, they are looking into this process and trying to evaluate.
Correct. Because you asked a very good question, because this is the question, even at 95%, 97%, will it be a bottleneck? Yes, it will be a bottleneck when business class you wear. So that's a beautiful question you asked for a TOC.
That I think Raga or Jaya asked that question.
Oh, sorry. Excuse
No,
me.
that credit goes to them.
Yeah, whoever.
Yeah.
That is the way you should look at it, and very well asked the question it is. Because TOC ultimately is for enabling the business. Of course, TOC, not everything else. But this is why, even because when you look at from outside, even 97% can become a bottleneck. As Tim said, no, he wants to use it, make it more, and use his labor on the other side. He wants to make it because he can sell it. Correct? If he's not able to sell it, he will not make it.
But they're talking about the OEE or maybe the availability of the machine, right?
Yeah. Correct. Well, see, the question from a third party perspective is why at 95%, 97% is still you call it as a bottleneck?
Okay, got it.
Because the bottleneck is driven from the business constraint.
Yeah, based on the flow and the actual demand.
Correct. Because if Tim doesn't have order, why at all you should consider this line? You will consider shutting down this line and
Correct.
using everybody else outside.
Yeah, agree.
Yeah, you will take it, use a resource some other place where there is an order.
Yep.
So the
Perfect.
business angle, always look at it from business eye. Yeah? That is the beauty when you start growing. Anything you should look at from that angle. Then you will see a bottleneck or a non-bottleneck.
Perfect.
Good. Thanks,
Any
Sanjeev.
questions?
Sorry for interrupting.
No, sir. This is very good discussion. Thank you.
Mhm.
I was I was just looking at how different this is with the D2D, door to door, and the VST mapping. I just looked at and then I realized like there is a difference. TOC is used just for the bottleneck to remove the bottleneck, but VST is used for the removing the waste. It's from the entire process. So I was just not getting that, but now I got that point.
Yeah. So VST stands for value streams
Yeah,
transformation,
still mapping.
or value stream mapping they call it. Yeah. Good. Very good. Thank you, Tim.
Yep.
Any other questions? So we'll move on to the next tool.
Yes, thanks, Tim, for this great share.
Yep, absolutely.
Yes, Sanjeev, I have one question regarding the third step of TOC where you mentioned subordinate everything to constraint.
Correct.
And that which explains limit the space of non-constraint items to support constraint, right?
So
That is what you mentioned,
so
right?
what this means is basically if the other processes are not really, if they are providing the right flow to this bottleneck, and you don't have to spend time on the other processes. Just make sure that the flow is right, and then you focus only on the bottleneck. So basically what it is saying is yes. Okay, let me bring that slide.
Yeah, because see, at constraint bottleneck, I am producing 141 parts,
Yeah,
as you mentioned. And if non-constraint machines could able to supply
correct,
more than the amount of quantities which required at bottleneck,
correct.
so that limiting pace at non-constraint stations will not be like it's underutilizing productivity of non-constraint substations.
Yeah, it is. But ultimately, think from a business perspective. Even again, that's how processes are sometimes designed. But if you go and improve that process, which doesn't make sense, it's waste of money and resources, right? So you will be utilizing your time effectively where you will make more money. So that's where, even though other processes are much higher in capacity or providing the demand, you will always focus on where you can utilize your resources and where is the bottleneck, right? So what this means is always focus on the bottleneck, and once you crack that bottleneck and you think, oh, next station now is a problem, then you go there. Otherwise, we always, business has limited resources, limited money, limited capital. So you have to be really thoughtful about where you want to use all the resources.
Sanjeev, another approach could be like instead of limiting the capacity of non-constraint items, we should focus on increasing the capacity of constraint station, right?
That's what the bottleneck analysis, right? Capacity, correct? Not limit, but always look for the constraint, and wherever you have a capacity issues, basically you're talking about the bottleneck only, right?
Yeah.
That
The statement like in subordinate everything else, make all non-constraint steps feed the bottleneck at its pace.
correct.
That is where I'm confused.
So what this means is whatever is all other non-constraint steps are there in the previous or the after the bottleneck, you have to make sure everything is feeding to the bottleneck at its pace. Means you have to focus only on the bottleneck. So if imagine the process A is having 3 minute cycle time, and you think bottleneck is process 3, which is 2.5 minutes, it is not feeding at this speed. The bottleneck is somewhere else. So you need to feed that. So what it means, if your process 3 is bottleneck for 2.5 minute, you always make sure everything is, all the non-constraint steps, right? Previous steps are feeding to the bottleneck at its pace. Means make sure your bottleneck pace is continuously flowing. Otherwise, you will stuck in that entire flow. That means.
Sanjeev, I have a question. Tim, can you please return to your sheet?
Okay.
So, Sanjeev, what I could understand is that this first cycle, okay, whatever is that these two robots are doing, they are not feeding at the rate at the rate of what second machine is processing. And
Correct.
further to that, so that is the non-availability of load a bottleneck then?
I didn't get your question.
My question is that because your first station is the what you are saying is it is not
Bottleneck.
feeding at the rate which is required for the working time cycle of second stage. Okay,
Correct.
so how because there will not be any like stockpiling etc at this stage, first stage.
So let's only simple maths here, right? Kaushalendra, talk about the cycle time of bottleneck. What is that? 13.6 seconds. So for every one part, I'm taking 13.6 seconds to produce that part, manufacture that part, right? Come to the second stage and think about how much time you are taking to produce one part, 10.10 seconds. Third one, weld at 12.10 seconds. Fourth one, 10 seconds. So now imagine all these machine. The last machine is giving you one part at 10 seconds, second last 12.10 seconds, third 10.10, 13.6 seconds is the bottleneck, right? That's where the constraint is because all other processes are flowing very fast. You'll get it, whatever you want in 10 seconds, but this is not giving you. So no matter what you do, imagine you increase your Pierce line by another 2 seconds. Will it impact? No, because
No.
so that's where you have to focus on the first station, and that's where they're tracking the 13.6 second to again further less. So that if that brings to 10 second, Tim brings that process to 10 second, everything is on time, demand, right? So it's flowing consistently. So you'll produce more parts.
Okay, got it.
Perfect. And then if you have further question, we can take this. So let me go to the next one now. We have 5 more tools to be discussed, and I will be going a little fast because probably most of you know. If you don't know, stop me again. But I want you to understand those tools as well. Any other questions before we move on? Okay. The next one, 8D. What this is? Why they call it 8D? Do you know? 8D problem
eight disciplines.
Correct. 8 disciplines. So there are 8 steps in solving any problem. And this is widely used in almost automotive industry, and most of the customers ask you if there is a problem because of your process or you are a supplier, they will say, hey, send me 8D. Means what are you doing to solve the problem? So the first, it is almost team-based 8-step process to resolve any complex problem or recurring defects. Means if the problem is coming again and again, and customer is getting irritated, they will always ask for, hey, give me 8D. So the first step in any problem solving with using the 8D, the first step is form the team. So you should know who are all to be engaged in solving that problem. Imagine you are getting continuous problem of there is a problem, or I'll use, okay, for a non-manufacturing, what kind of defects a customer may get. For example, imagine there is a wrong label or the wrong box that you ship to a customer, right? Then you don't know why. Then you first, okay, engage the cross-functional team. Make sure that everybody, right, from packaging, engineering, operations, supply, everybody is engaged. Then 2, you will define the problem. So when you define a problem, you always use 5W2H. Who can tell? 5W2H. Already there. 5W is what, where, when, who, why, right? And then 2H is how and how many. If you have this in step 2, then before jumping to step 3, make sure your step 2, D2, discipline 2 is very clear, right? What happened? Where this particular problem is coming, right? When happened? Which shift is happening? Is it only on this shift or second shift or third shift? Who are involved in that process? Who should be involved in the process, right? And why this is happening? How it could happen? And how many pieces are impacted is where the second step. Then third is containment. Don't jump to the solution. First, protect the customer. That's what we call it. Containment is all about make sure your customers are getting good parts from the moment you know there is a problem. Stop the bleeding, quarantine all the product and inspect, start putting inspection gates so that you are now starting to feed the customer with a good product knowing that there is a problem, right? That is step 3. So protect the customer. Then step 4, use some tools to do the root cause analysis. We'll go deeper in the next tool here. Is and is not matrix. What is basically, okay, what should happen the way it is designed, or what should not happen, right? That is, there are always good things. There is always something that we always think that, hey, this is not how it should be, right? So good, acceptable, not acceptable, kind of is or is not matrix. And there is another tool, Fishbone. We'll talk about it. 5 whys is a great tool. We'll talk. So use those tools in step 4. Then once you identify the root cause, then D5 is what is your permanent fix? Select that solution that is eliminating. You know the root cause. You exactly understand what is happening. Make sure you go and fix that problem and validate, right? Make sure that whatever the solution you are saying, like for example, I'll give a very simple example. The light bulb is not working. I don't have light. It's a dark here, right? Now I try to check the bulb is okay. I try to see switch is also fine. And I also check electricity is fine. Then something in between is a problem. So I tried to replace, or I found that, oh, there is a loose connection on this particular holder. I put it back and it started working. So now, how do I know whether I fix the problem? I'll take that again lead out and see everything is still, it is off, and I put it back, it's on. So I know exactly the problem is this, or you need to validate the problem basically. Then D6, implement it, make sure that your effectiveness, like I said, on and off with whatever the data. SPC is a statistical process control, just to make sure your process is capable to meet the required design or the customer requirement. Before and after, hey, make sure everything is right. Then D7 is very important. That's where most of the organizations do not use this step. We go and fix, and then we do not really think about recurrence, right? So we don't go and update all the procedures. We don't train people, and also there will be other processes similar to this. This problem could happen somewhere else also, or it can happen say in the same process. So it can happen in one shift. You call all the people, everybody knows, but second shift comes, again you have the same issue because they were not updated. So prevent the recurrence. Make sure everybody in that process learned about that problem. They understand what not to be done, what to be done. And then the D8 is basically celebration, recognizing everybody, hey, we solved this problem, this is what happened, lesson learned are shared across the organization, and this is how you solve problem using AT. So how to use? Whenever there's a defect occurs more than once, or a customer complaint value, whatever, I'm just putting the number here, 50K, assign first of all D4 owner before any fix is approved. D4 is root cause analysis. Who has this problem? Who should be leading the problem? Once that is done, then follow the steps. This is the tool framework, and then we'll go to the next one to talk about a critical example, right? So the problem here is engine gasket defect. So just for a manufacturer team, but we can take any other as well. So first, basically defining, right? 3.2 D1. D1 is problem definition. 3.2% defect rate on engine gaskets, almost $2.1 million per year in scrap and rework. This is a problem. This is what they want to solve it. And D2, define which line it is concentrated. Okay, it is in the afternoon shift, which is second shift, and it happens post lunch hours. And D4, root cause analysis. They did all the tools we talked about. So they found out hydraulic press calibration drifts after 200 cycles. There's a drift happening. There is no automated alert, and that's where the defects are created. That's where the scrap is generated. Then line 4 quarantined, 100% inspection added immediately. We know that this is the problem. Then just an example implementation, they've added pressure sensors and then added SPC, the statistical process control dashboard, which will alert the operator in real time. Hey, this process is going out of control. Then they completed the FMEA calibration, and then they reduced, from weekly to every 150 cycle, they go and calibrate so that it should not drift. The result, defect rate fell from 3.2 to 2.18% within 90 days, and we saved almost $2 million, right? So 94% of Fortune 500 companies use 8D to solve their problems. So 60 days is the average time. Normally it takes from D1 to D8 for a very well-defined problem. And then if you are the leader, always make sure, hey, use this tool. Give me what is exactly, ask for D4, ask for D7, because those are all important. And then you can use it for, if you want to approve any CapEx, anything, you make sure that, you identify the root cause and then you have fixed it effectively. Just an example, however, those who are in not manufacturing may face a little bit, but this is very, very simple. But once you understand these step 1 to step 8, you can solve any problem. Anyway, I'll stop here and then see if anybody has any questions. And I think I talked very fast here, but I'm open for any questions or anybody wants to share anything on 8D.
Yeah. So fault tree analysis is another, what I say, a good tool to determine your root cause.
Yeah. So fault tree analysis is for
Sanjeev,
when something happened,
is
you
it
go into it.
possible
Go ahead.
that there could be many root cause might be any
Kaushalendra, we couldn't get it. Maybe you are breaking off in between. Yeah, I think he has got some network
we
issues.
lost, yeah.
Yeah, anybody has any? I think maybe this is a little bit complex, but it's not that complex. Those who use this tool. Yeah. So you talked about Harsh.
Yeah.
FMEA, fault tree analysis. Fault tree analysis is another tool. They use it kind of basically they talk about physical and logical, right? So,
Logic, yeah.
yeah, physics and logic. So something happened, then you use that tool, right? But this can be used even for potential problems also. Hey, this is how we can use. So fault tree is okay. This happened. That is how they will branch it. So FTA is a great tool to solve problems. I agree.
Yeah. So
Sanjeev, this is something similar to 7-step problem solving.
Correct. 7th step is where Cummins uses for solving problems. They just reduce one step, but ultimately is the same. So we start with not form the team. We start with ultimately defining the problem, which is D2, right? So that's how we'll start. Yeah, you're right.
Okay.
Sanjeev, I have a problem. I mean, I'm supposed to solve a problem at my workplace right now. It's a very simple problem, but I'm just thinking which tool is more effective. Say we have status reports to be given to 8 different leaders, and the time consumed for each status report, even on an average, was 30 minutes. Across the teams, it's a significant amount of time. So what would be a right tool that I could leverage to I mean,
So,
it's just status reporting.
okay, very good. So now, how many reports, how many people, and do you know who is taking more time?
Yeah, I don't have all those stats. I mean, from our team, I know. Basically, our team we are feeling it as a burden to provide so different formats. Same status in different formats is a major concern.
So I think we'll talk about one Pareto tools. First of all, get the data, a little bit of, where, see, if you have 5 teams, just for the sake of this example, team one, team two, team three, team four, and then, team one takes, hey, 20 minutes, team two takes 40 minutes, team three takes maybe 1 hour, team four takes less than 40 minute again. So, and then once you know, okay, this is what, and then you go, there could be multiple issues here, right? So which tool to use? It all depends on, it could be, easy solution like that. Use AI, it will generate like this and then it will give you all the reports in instantaneously. If your data is so correct and you don't have to do any manual intervention, you can do so. But I don't want to jump to the conclusion. If you use the structured problem solving, first of all, define the problem. That's where you need to end. So when you are to define, you need to know, okay, what's happening. So we talked about all those, 5W, 2H. Then once you get that, you'll come to know, oh, this is what happening. Go talk to that department and find out, hey, you guys are taking this much time. I'm here to help. We can, then in that particular process, think about, this is a 30-slide presentation and somebody giving 10-slide presentation. Somebody is giving only 5 KPIs and he takes only 5 minutes. So wherever the bottleneck is there, and then think it is also not their problem. There is a system constraint because they are dependent on someone else now. Now you need to go and talk to that person in order to get this report on time. This particular report has to be generated maybe a day before or 2 days before. So identify the problem and then go attack it. You'll be able to get that. So it's all about communication. To me, it is all communication, understanding, and figuring out who needs to do what, and then providing them a solution which will be easy for them. So once you make their life easy, they'll always say, yeah, this is what we can do.
Yeah.
Sanju, something similar we had earlier. I think still it is there partially like different leader. The recognition slide is different. Somebody need a name, somebody need a photo, somebody need a description, and it's the same one. We are recognizing for a same, but we have to give in a different format. And maybe the point is we have to look at is there a commonality in that one so that we can reduce time.
Yeah. So it is very simple,
Because
right? Standardize
yeah,
the format.
Standardized process, yeah.
Yeah,
yeah.
standardize the format. You say, hey, leader one, leader two, leader three, all the format and see what they're asking. Create one with all everything everybody is requiring and say, hey, you know what? We'll use this standard and then align everyone. Say, hey, here is what we can do. So that way people are not spending too much time.
Because I just still reminding the Krishna sir's post, hammering on the nail. So it's not required every time we used to use the tool. If it is a simple one to just standardize our understanding with the different leaders, or maybe a automation of that one like a bullet, buttons. Like for this leader, these are the data required. For this leader, these are the data required. And then the Power BI or something can give a every month it can give a the entire this one the presentation. Just we have to select what is required and just refresh it. It will automatically give all the data.
You know what I did? For all the reporting, I created an online Excel file or the presentation, and there are global teams, right? I can't get all the 10 people, do all the email and consolidate and send.
Yeah.
So what I did, one presentation kept online. Everybody should work on that presentation on their portion, and it should be ready by this date. I don't even go and talk to anyone. And if they are not ready, then I go. However, by that time, everybody's presentation online and then you can just submit. So
Yeah.
make it more. Nowadays, there's a lot of tools available in cloud, right? Teams folders, such a great thing. If you create a Teams folder and put everything online and keep it there, you can edit everybody same time, right? So just few examples, but I'm going moving on to the next tool, and just to give you an example, complex problems are much more complex. Sometimes you don't even understand. Imagine an engine has got about 35,000 parts, and somewhere something is happening and something failed. Now you need to identify why that failed. It could be because of customer, because of your all complex assemblies, because of something in your supplier processes or your own manufacturing. That's where you need these tools, because then you really need the expertise to understand. Okay. Yeah. So Kaushalendra, okay. I'll move on to the next one very quickly, and then we'll come back. 8D we talked about. Then this is a very important, very commonly used tool. Okay. 5 why analysis, and very simple tool. Anywhere there is a problem, you can use this tool. There is basically you're asking every time why. So you go to the root cause. Maybe depending on what normally people say, when you ask 5 times, you'll go to the root cause. Here is a great example, right? E-commerce platform down for 4 hours. Okay, we lost about 800,000 revenue. Why? The web application threw a 503 error and crashed. Why? Database connection pool was fully exhausted. Why? A new feature release contained unoptimized SQL queries. Why? No SQL performance review gate existed in the release pipeline. The root cause: engineering checklist was never updated to include database performance criteria, and that's how they fixed it, right? So how to use this? Always ask why only after verifying the previous answer with data. Stop when the answer is something you can actually control and change. So it's a very simple tool, and you just keep on asking until you find the root cause. Then just a practical thing, right? Problem: 22% of customer order delivered 2+ days late, costing NPS point. NPS is Net Promoter Score penalties, right? So why? Trucks routinely leave the warehouse about 40 to 50 minutes late, behind the schedule. Why? Picking operation consistently run long, average 112 minutes versus 78 minutes target. The why: then pickers walk inefficient routes, travel time is 38% of their total task time. Why? Warehouse management system doesn't optimize pick path between zones. Why? WMS zone skip algorithm was never enabled, whatever with up to 18 months ago. Fix: zone skip activated plus slotting review run. On time delivery rate rose from 78 to 94%. So ultimately they're talking about the algorithm here, which is the fifth why. But Raga, to your again, keep on asking this question: why? You'll get to the root cause and you can fix it. Okay. So 48% faster incident resolution versus trial and error. So just asking why. 60% reduction in repeat incident after 90 days. So always you require 5 why for every IT incident before a ticket close. Just ask, and then ask this monthly ops review as a standard format, and then always use this with data, right? So it's a very simple tool, but very effective. Okay, most of the people use this in almost all the industries. Any questions before I jump on to the next one?
Sanjeev, I had question on previous AD tool. Just quick, like how it is very important to follow the steps in sequence, or by considering importance, or we can adjust the steps. Like if you require more time to define the problem, can we quickly do the containment or any very quick solution?
So sometimes even asking 3 times, 2 times, but once you do not know the second why answer, you cannot go to the third one. So if the first of all, make sure the first is logical and it's right, then second, then third, so don't jump to the fifth one until unless you know the exact. Otherwise, you have not solved the problem. You do not know the actual root cause, right? So it can be even sometimes asking 2 times. Oh, why? Okay, because you already solved, you know it. You don't have to go to fifth step. Okay, you go and do this and make sure that it doesn't happen again. Right? So it is not like thumb rule, you have to do only 5 times or this. But as long as you know the root cause is addressed and it is not repeating, you fix the problem.
Hey, Sanjeev.
Yeah.
The only thing I'll add too is that like a lot of times when we do the 5 why, we do more than one 5 why, right? Like one of them for technical occurrence, one for detection, and one for systemic.
Correct. I'm with you. Yeah, and it's not for systemic problems. You're right, Tim. That's a very good point because there is a detection problem, there is a prevention problem, there could be systemic problem. So depending on where and how you are using, but it's a very easy tool to apply. And this is easy to teach also to people. Now I'm moving on to one of the complex and very, very important tool that widely used in almost all industries. This is very important, and I'm covering here DMAC, which is, define, measure, analyze, improve, control. They call it DMAC, Six Sigma tool. So here also there are 5 steps. First, define the problem. Make sure you understand the problem correctly and scope it, right? If your scope is too big, it will take months and months and years to solve. If it is very small and you're using the complex tool for a very small problem. So you have to be very careful about where you want to use this, right? So this is data-driven 5-phase methodology widely used in industry to eliminate defects and reduce process variations. And I'm a Six Sigma black belt. Even Krishna sir is master black belt. Some of you may be having green belts and black belts. You all know this works. And this is how most of the larger companies like GE, Motorola, everybody use this, and there's a tremendous success of using this tool. The first step is define. So understand the problem, write team charter, what is your scope, what is your business case, justification, why you want to solve this problem, and the timeline. Second one, measure. Because if you don't measure, you can't improve, right? Baseline, current performance. So why you want to solve the problem? Where is the problem? So put together data and then understand your baseline, and then make sure your measurement system is right. Because if your measurement system, what you are measuring, if it is not correct, you do not know whether you have improved or not, right? So, and calculate your current sigma level. They talk about, Six Sigma is basically, 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma. So 6 sigma is basically statistical when 3.4 defects per million. So if you are producing 1 million parts or 1 million transaction, so maximum allowed defects in that process is almost 3. So it means ultimately 0. That's how they think. So imagine those many transactions, and then you are having very, very less variation in the process. Then you will be able to achieve that level of defects or the Six Sigma level. Then in the M stage, okay, in the define stage, you can use CTQ, critical to quality tree, SIPOC. I don't know whether you have heard. SIPOC stands for very simple. So your supplier, input, process, output, and customer. So it is the flow from supplier to the customer and including your organization in the middle, right? So S stands for supplier, I for input, what inputs you get to that process, then what is your output from that process, and who is your customer. Understand that, map it out, right? SIPOC. Then have a charter. That is what you do it in define stage. Then measurement, you use a tool called process sigma. We talked about, right? 1 sigma, 2 sigma, or ppm, whatever it is. Then CPK, PPK. These are all statistical terms. Those who do not know, CPK stands for short-term process capability. PPK stands for long-term process capability, right? CPK, based on my Cummins experience, we always short term, minimum 32 parts, you measure everything and make sure your CPK of that process should be greater than 1.67 in a statistical terms. And PPK is which is a long-term capability which considers all the variations over a period of time. It should be at least greater than 1.33. Okay, so we'll talk about it a little bit, but those who want to learn, they just reach out to me. I have lots of templates and then also training material on how do you calculate CPK, PPK, and then MSA, etc. Right? That is the measurement. So first of all, you're identifying, okay, what is my baseline and how I'm measuring my output, right? Whether it is really control measurement or measurement will change. That's what. The third step, analysis, right? Here you use a lot of tools to make sure that you identify the root cause. In 5 Whys or D3, we talked about only, okay, go do check and then try something. But here there are a lot of tools you can, statistical tools, right? There are a lot of tools like regression analysis, hypothesis testing, ANOVA. There are multiple tools you can use to identify the root cause. And statistically, you can validate, hey, yes, this is right, or and then you can use Pareto chart. Pareto will talk after this a little bit what is Pareto chart. Then improve is basically design. Once you identify the root cause, the next step is improvement, right? Design, pilot, and validate the solution. Make sure that whatever you said in step 3 analysis, you make sure it is validated and use DOE. DOE is design of experiment. Make sure your experiment and make sure the problem that you stated, the root cause, is validated and there is a simulation to optimize before full rollout. So if there is anything to be done, make sure it is understood and with design of experiment, confirm, right? Then control. The last step is control. Then you have put a control plan, lock in the gains, you put SBC chart or any SOPs to be released, people to be trained, handoff to be done to the process owner. So that's how you will close the project. So DMAC is normally, it's used with the greater problems or the complex problems where you have greater than 500K, 200K, whatever the threshold your organization has. And it may be sometimes 3 months, sometimes 6 months it takes to solve the big complex problems. And make sure your scope is right, one process, one metric, and make sure that you assign a green or a black belt as a project lead who understands these tools, who knows how to solve the problem, how to engage other cross-functional team, and you can solve any complex problems. So ultimately, it reduces your process variation and it solves the problem with statistical analysis. Once you solve it, you will gain a lot of benefits, right? So DMAC in action, just showing you how the 41 war supply stockouts per month causing surgery delays. Sigma level was 2.1. They defined the problem, reducing the stockout, greater than or equal to 80% in 6 months. Scope was 12. High risk SKUs is basically, SKUs is basically the entire the container or the SKU that they call it, the package. Then the major data, they did all the analysis, they used different tools. There were 68% of stockouts in just 3 SKUs that they confirmed with Pareto analysis tool. Then they did analysis based on whatever last 3 years data they had. They found demand variability ignored by ERP. So ERP was not considering all the demand. Then in the improvement process, dynamic reorder points using ML based machine learning based demand forecast model they implemented. Then weekly automated inventory dashboard plus SMS alert below fair safety stock was put it, and then the result was they reduced from stock out 41 to 4 per month. Then Six Sigma now level improved from 2.1 to 4.8. They saved almost $3.2 million, right? So just an example. So make sure that you have the right scope and you have right measurement and then right team who understand the statistical tools, how to apply that. This is how the industry is used, but this is widely used. And if anybody wants to wear green belts, black belt, it will be a great advantage for you to apply this tool and then improve the process and solve problems. I'll stop here. Anybody, any examples want to share on Six Sigma? Anybody is a green belt or a black belt here? Okay, great. Tim. Okay, good. Harsh. Hey, good. Krishna. So we have some Six Sigma belts here. They definitely, if you have a Six Sigma project, you want to take yourself and use these methodologies, reach out to any of us, and then, or you are working or you need some help, you can also help. But that is a tool widely used. That just I wanted you to be aware. Okay. Then next two tools are very simple, so maybe we'll try to cover in 5 minutes, and then we'll have a discussion. Pareto principle, very simple tool, very effective, and I encourage everyone to use this. This is one tool that I always use it. 80-20 principle, right? 80% of problems come from 20% of the root causes, and then 80% of revenue comes from 20% of customers. You all know this. And then we also have 80% of delays come from 20% of processes. This is focus on the vital few, not many, right? The Pareto is always talks about, because you cannot work on 100 problems, but definitely you can work on the top 2 or top 3 problems with your team. So this principle works very well, and the name comes from a scientist who discovered this tool. His name was Pareto, and he discovered and said, in almost, he analyzed all the problems, all the statistics, natural distribution. He found out that 80% of the problem come from 20% of the causes. 80% revenue comes from 20% customers, right? So how to apply? Collect and categorize your problems or issues, quantify the frequency or the impact, then rank from highest to lowest, maybe use an Excel file, calculate cumulative percentage, then focus your resources on top 20% and drive that will drive 80% impact. Work smarter, not harder, prioritize what truly matters. This is a tool, and this is widely used. I think any questions on Pareto anybody wants, because even you do Google or even Excel has this tool, so you can go and then start using this tool.
Sanjeev, I read an interesting book. It's called The 80-20 Manager.
Oh, cool.
And essentially, it talks about the 80-20 principle, not just in application to problem solving and things, but in life in general, right? Think about anything you do, and how you're allocating your time as a manager or a leader, focus on that 20% of things that are going to get you 80% of the result.
I'm with you. Yeah, correct. So one of the thing what I always use is when somebody comes to me with problems and say, hey, we have this, that, then I always talk about, okay, even there are 10 problems, I always look at, okay, where do I need to put my entire focus or attention? Top 20%, right? This is a good one. I like that. And I highly recommend that book even to read and then understand. That way you are not, having so many problems and you feel, burned out. Better focus on certain thing and then get those results, right?
Adding to what Tim said, just it can be applied on everything that you do. Like, when Lavanya asked last time, I want a lot of things to be done, but how do I prioritize, right? We all want to do a lot of things, but prioritize the top, 80-20 there too. What are the 3 things that you get 80% of productivity or 80% happiness or 80% things done? Yeah, everywhere you prioritize those, because we all want to do a lot of things. But yeah.
Cool.
I know
Very
this is totally foreign to me, all these things, but I can relate to how it applies even in my area, in my HR systems too, which is very interesting. Now I'm like thinking, how do I use this? How do I use this? So it's my mind is running too fast. Yeah,
cool.
but it's really good. Yeah. Thank
Very
you.
nice. Thank you. And then now I'm going to the next one. This is A3 thinking. They call it lean thinking. How do you, this is also a simple tool. One page, it gives you a visual statement that aligns teams and drive for. So imagine you have 20 people team on the floor that you go and want to really talk about a problem and how to solve. This is one board. The A3 is basically, the papers, right? A3 paper, A4 paper, we have A5 paper, different types. So A3 is a little bit bigger, larger. So all these 6 steps can be accommodated on that paper. So that's why the name is A3, because normally when lean or operation excellence team, they use A3 because that is a larger paper and they use this framework. That's how the name came in, right? And first in this step is background, right? Why does this matter? What problem you want to solve, right? Link to the business strategy or KPI, which KPI you want to improve, you want to quantify cost, quality, safety, delivery, whatever it is. And second, figure out where are we today, why we want to solve this problem. Process map, data chart, what is working today, what is not working today. So talking about current state, highlight the gap and standard, right? Here are the gaps, here is what we want to go, right? That's second step. Third, target state. Okay, here we want to go and this is my goal, and if I solve this problem, how it looks like, right? Smart metrics, reduce work, rework 70%, right? If that is a goal, you want to reduce your rework by 70%, then you need to know, okay, that's what my success looks like, right? By this particular end of June, and then I don't want to invest any capital, right? That's the target. Then fourth, use any tool again, root cause analysis. Like we talked about five whys. Fishbone is like fishbone is also a name comes from, when, I don't know, if you eat fish, when you take out all those meat, everything, there is a bone, right, that remains. So there will be different legs, kind of thing. And then at one leg talks about man, machine, method, material, mother nature, all those things comes in fishbone. So if you Google fishbone, it's an easy. So you'll see the diagram. It looks like a fish. Value stream mapping, you can use that. Like we talked about Krishna Reddy, just talked about VST. Then make sure the data is right. Never assume the cause, and circle the deepest actionable cause where you want to work. Then fourth step is root cause analysis. Use any tool. Fifth, what are you going to do? Right? Countermeasures. Who is going to do what by when? This is very important. Normally in organization, I've seen people always say, we have to solve this, we have to do this, we have to do this. But people don't assign who will own that responsibility and by what time, and then by when it will be completed. If we don't have that, then it is not an action. So whenever somebody says, I'm going to take action, always ask 2 questions. Okay, who is the owner? By when it will be done? Right? Then not a paragraph, action table, right? Who and by when, and then root cause, not symptoms. A lot of people work on symptoms, but here the focus is on the root cause. And then sixth is follow plan, right? Use plan, do, check, act, make sure that everything is done. There's a metric, there's an escalation, and knowledge is shared, right? So every A3 fits one physical A3 sheet. That's what they call is no bullet, draw chart, map, complete in 2 to 4 hours with people who own the process, replace 30 slide deck with A3s for all operational decisions. If you have an operational issue, you want to solve the problem using the team, this is a tool, okay? Just an example, I'm not going to read, I'll just keep it for you to go through, glance through this, and then we'll come back. Moving on to the next one, very important last tool, FMEA, they call it failure mode effect analysis. This is widely used tool in manufacturing industry for risk identification, but it can be used anywhere. This is a great tool to prevent a particular issue because you are trying to identify the risk before they become real failures. So this is a tool to identify, score, and eliminate risks. Okay. So
hey, Sanjeev,
yes.
a quick comment on this. So I see that you have there like action required when risk priority number is greater than 100.
Yeah, I agree with you. That is
So,
not what you should be. You're right.
Yeah, but I like, that's why I like the AIAG/VDA version of the PFEMA, where the risk priority is not weighted equally between severity, occurrence, and detection.
I'm with you. I agree. I think this is a little bit of older version, but I think we need to be thinking now they are talking about only SO, right? Not about D. So because when the severity is high and occurrence is high, you take action, not on the RPN number. So then, yeah, I agree with you.
Yep.
For others who do not know this tool, this is the old one, but the new, there is an AIAG manual that talks much broader and much deeper than this. So this is a basic level we use about 5-10 years, but the new one says you have to focus on SO, not SOD. So this is kind of an Excel sheet. You can have column one is what is the process step. In that process, what can go wrong? And then if it goes wrong, what is the business impact? And then there are three important metrics here, numbers here. One, they call it S, is severity of the problem. O, occurrence, how many times it can happen or it happened. D, if it happens, can you detect it in your process or in your organization? And then the combination, the multiplication of SOD is RPN, what is called as risk priority number. But now risk priority number was earlier, and we used to always think about, you always go and identify top 20% here and then work on them. But now AIAG, which is the standard, automotive action group, is suggesting don't focus on RPM, focus on only severity and the occurrence. And then based on that, you have to prioritize your action, right? So some of the examples, it's like conveyor sort, belt jam, it is 45 minutes, then action is add a detect sensor. Server backup fail, process is server backup, failure is backup failure. What happens if it happens? Data loss, recovery. We calculate, okay, severity is 9, occurrence is 3 is basic. So all this SOD, 1 is lower, 10 is the highest. So only 1 to 10, okay? Remember that. And then even occurrence also 1 to 10, D is also 1 to 10. All this multiplication is RPN. So daily automated verify. So some of the examples, right? How to use, basically, if you want to launch a new product, you want to launch a new system that is going live and process change, and use SO or SOD honestly, and always review annually for all tier 1 processes. Okay, now I don't want to go here again, same thing, how it is done, and then this is the summary of what we covered so far, right? Tool, what is the trigger, when to use it, where is the value, how much effort you need, and which top industries these tools are used. 8D, when there is recurring defects or a customer complaint, it may take days to weeks. Medium effort level, used in manufacturing, auto, pharmaceutical industry. 5Y, used in IT, ops, any industry you can use. DMAC, you can use in any industry. A3, supply chain distribution. FMEA, you can use anywhere. And then also TOC we talked about. So with that, I'll stop here to share, and then we'll have some discussion if you have anything. Hope you got the glimpse of where there are multiple other tools, but I think this is how you solve problems, tactical problems, and then you will be able to go deeper and then resolve. And once you learn these tools, apply, you become, really a go-to person in the organization. Any comments, questions? Anybody want to learn anything else?
Sanjeev, just one quick question on FEMA, particularly to automotive components, as far as severity is concerned. 9 and 10 severity is concerned for compliance related or threat to human life. But as far as business is concerned, business problem or IT, how severity defines for business problems?
Good question. So severity normally because the FMEA is used widely in product launches and this is widely used for automotive. The reason it was used by automotive is because when you are going on a vehicle, something happens, there is a risk to the life of the person driving that vehicle. So for example, you are a brake manufacturer or you are an engine manufacturer. The severity of what happens if the accelerator thing stuck and your car, you can't stop it. So it can go and do. So this tool is very important to be used widely but for business problem, is nothing like what will the worst case, your profit loss, cost or something, bankruptcy, not going to, take human life, right? So we don't want to go beyond 8, but when it goes 9 and 10, it is more about human life. That's where this all metrics and everything came into. So for any business, I won't rate more than 8. No. Does it make sense? Any other thoughts, Tim?
No, I think that makes a lot of sense with regard to what you said for the FEMA. The only other thing I think about problem solving, if I could share real quick.
Sure.
Some people might be familiar with this. I know Sanjeev, you are, because I know you kind of sponsored the whole rollout of this at Atmos, with training, but using the Epic scoring system.
Yeah.
So it just basically what it kind of gets down to is, I think it's really important. I've been trying to drive this with my team a lot, is when you're putting a corrective action in place, it's very important that we try to aim for technical corrective actions rather than behavioral corrective actions. And essentially what this does is it kind of rates your implementation. And as you can see, anything you do that's technical and that doesn't rely on human behavior, you get a much higher scoring level. So I just think just the key takeaway there is when you do corrective actions, we try to stay away from behavioral things that rely on people's behavior, because people's behavior is inconsistent, right? But technical implementations are more robust.
Super. Thank you, Tim, for bringing this up, because almost everywhere you go, you always say, we trained the person and then he becomes a hero, and if he leaves or she leaves, then again organization have same problem. So behavior is always human based, technical is always system based. So we always need to focus more on technical solutions, not on you. Even also see on the behavioral scale here, when it is no error proofing, it is 0. And when it is defect detection at the downstream, if it is a behavioral, it is 1, and if it is technical, it is 5. If it is defect detection at the source where the problem is generated or created, you see behavior is 2, because you are dependent still on human. But again, if you put a technical solution, 10, it automatic score increase. And if you have an error detection, so error and defects, you should be aware errors are caused by humans or issues that we make because of our own manual working or the way we work. And then errors will create defect, because first stage, second stage, third stage, you are doing some work and you are adding some more errors to it, then the next process will take that defect. So defects are created by errors is where my mind, right? So always focus on error detection, because once you have error detection and defect prevention in the source, you will be able to solve problems. And then not only stop there, go for error prevention. So how do we not have those errors, right? That's where you will see the left hand side technical solutions is 20 score and behavior is 4 because still you are dependent on human being. And after level 5, you absolutely remove all the substitution and system will take automatically. Like, now we're talking about AI, and once you program it in the right way, system will run without having errors, like robots and lot of automation. Then you are not dependent on behavior, all about technical solution. That's where you will. So this is a great framework. Thank you, Tim. And this is developed by a lady called Mary Literal, whom I met, and I brought this into Atmos, and then Tim was at that point in our supplier space, and then he took it and ran away with it. This is a great tool to apply to solve problems.
Sanjeev, we call it as a engineering control also. Is it the same one?
Correct.
Technical.
Engineering, technical, same. You're right.
Mm.
Engineering, technical, system, whatever you call it.
Yeah.
Cool. Very good. So with that, I will open up for any other questions or anything you want to discuss as a group. I'll break into two, and then if you want, go ahead, discuss, and then come back. Or if you are okay, then we can also stop. So Krishna sir, any other thoughts, anything that we discussed so far?
I think excellent one, Sanjeev. One thought to share is this. You see, 80-20 rule is usually on the productivity OpEx side. When it comes to mindset, or possibly using emotions and things, it is believed. You remember that gate I put in the last presentation? There's a gate. It is believed that 90% of the problems that happens from emotion mindset is from that gate closer and open. And this is what Stephen Covey has also said. When it comes to that, you should probably move from 80-20 to take 90-10. So that you own 90% of the problem from yourself and 10% outside. So if somebody is feeling stressed, the issue is coming up, 90% we should blame it on ourselves for not, opening or closing the gate. And 10% is by itself. Let's put it that way. Just for people to think, in relation to what we had last time.
Very good, sir. Yeah.
And just another thought on FMEA, see, just to share with you, in one of the, I would say, world's big auto companies, we were making fuel lines. Okay. And when we did FMEA, this is just to share an example. Okay. That fuel line is so critical. It's so critical in any automobile. What happens if there's a sabotage? That is one of the FMEA that it was brought out. Okay, we have done everything. What if somebody does a sabotage on the line? So, for that, most of it is still operates this way. The solution is we have given, some sort of a online cupboard for the operator. As the fuel line passes the test bench and pasted out on the QR code, it will go to this lockable locker on the production line where key is with the operator. So the traceability, everything is preserved and no error of sabotage also. To that level, this was worked out. And this came out of FME, everything was done, and suddenly somebody from outside of assembly plant in India came out with this, because probably they've had an experience. So we couldn't say no, so then we stretched ourselves, and this was agreed. This was done for one of the biggest auto companies.
Great. Yes, sir.
That was the result from FMEA.
Yeah, FME is a great tool because I was designing one assembly line and we had lots of issues going to our customers, and I was ops leader on that line, and they pulled me and they wanted me to build an assembly line so that I build the line to not have any defect. And using my experience, we did FME almost 3 months before even I float an RFQ to the supplier. What that means, I designed every step of the line, consider all the failure, what could go wrong, how operator can make mistake, what can go wrong in the process and product, and defined all those processes, and then designed request for quote. Then we floated that quote to supplier. This is how I want my line. And then we got the quote, all things were budgeted, and then we started building that line, and we awarded to a supplier in China, and then that was so important that supplier did a really phenomenal job. And once I did that particular FMEA such in a nice way, the project was having like $1 million. We didn't have a single overrun of thing. Everything was within budget, on time, and that line delivered zero defects. Nothing from that. And then we did everything on time. But the FME is such a great tool. That experience really taught me, like, I would not have done that if I would not have had the experience of operations and everything. So having that experience and this tool really helped us develop that line. And then if you go today, even in India, this line is running and everybody prays, and we got big award for this because this line was designed with lot of risks that could have happened because of other if you have missed in the RFQ process. So just to share an example.
That's a good example, and really it's unfortunate like how bastardized P-themas have become sometimes, because people just copy the previous one, right, and submit it with the PPAP. But it's such a great tool if they really use it right.
Correct. You have to use the tool, and I personally got such a benefit. And then they always use call this guy is a FMEA champion, because I used to always think in that and then design those, and that really helped me understand that tool and then what it can deliver. Good.
Excellent, Sanjeev. I have one question. FMEA's internal view. What is a similar tool for the external view for the customer?
SWOT analysis.
No, same like this. For
Yeah,
external, from a customer view. So, no,
Okay.
I'm telling from a product perspective.
Oh, I see. Okay.
FMEA is more internal. I thought this question was come from a operations team. Why do you look inwards into the product? What about the customer? So customer has something called the error mode effective analysis.
Or the design theme.
The customer is going to do this error analysis. How is the error internally diagnostic system is going to project to the customer when he's using the product? Will he be comfortable seeing it? Will he be able to easily understand POS? Sorry, I am on the road, so you'll hear this sound. So this is called error mode effective analysis.
Oh,
This is
yes, sir.
from
So what about CFD?
Sorry?
Oh, yeah, that is also internal. CFD, right? There's
CFD is internal. Everything is internal. This is external. So now you wear the shoes of the customer and then say, okay, if I'm using the product, what's going to be the error it's going to throw? And this error, will it give me a sufficient knowledge, understanding of whether it is my problem, system problem, error problem, or handling problem? What is it? Or it's a life of a component problem? Replacement can be a solution, or a service engineer should be called, or is it critical? So that we do error mode effective analysis.
Very good. Yeah. I think maybe that's the basis, Tim, that Mary came up with this, the ladder, we talked about, because we always talk about error detection.
That is implemented into the ladder later on. Because when you do an error mode analysis, then you decide to do that's an output of the error mode.
Yeah.
Then you redefine the ladder. You rewrite applications, you rewrite programs, you rewrite interfaces. Enunciate and panels change. I mean, just a thought to add when you're looking at tools.
Very good, sir. Yeah. Anything else, anybody? So if not, then we will, stop here and I'll share the recording, as well as if you have any other questions on tools and anything you feel like to discuss more, we can talk. And next week, what we are going to do, we will continue with our sessions with Krishna sir, and then we go deeper, and then everybody has prepared their presentation based on the sessions. Let's go deeper there, and also we'll have more discussion, and then also if there is anything to be discussed or learned, we can take it next week. Thank you so much. Bye. Have a great day.
Thanks, everyone.
Thank you.
Thank you.
Bye.
Great information, Sanjeev. Well put. Yeah, thank you.
Thank you. Bye.
Bye-bye.
Thank you.